So there's a couple of major things you need to think about. There's the physical properties that you need to drive in the materials to survive the application itself, the heat, all the things that are going on in your environment. There's the materials aspects of surviving the maintenance operations, cleaning being a good example. There's also the material selection that you need to do to make sure that you don't alter the part for post-processing steps. So let's say I'm handling a metal part that subsequently is going to go through a coating or painting step. You need to make sure that the materials that you select don't leave residues that poorly interact with downstream chemistries. So all of this goes into creating the appropriate material selection for a soft robot. So all manner of food is a fantastic application for us. So if you think about it, there's no such thing, for example, as a regular piece of broccoli. When food comes down a conveyor, it needs to be packaged. Every piece, even though they may look the same to a human, to a robot, small degrees of variability can ruin an application, at least for a conventional system. So, every piece of food varies a little bit in size, weight, shape. Many pieces of food are remarkably easy to damage. I'm proud to say that our grippers actually do less damage than you might yourself just handling a piece of food. So you need to be able to offer that ability to be delicate. And then on top of it, you need to be very, very cleanable. So going back to the Terminator hand idea, if I have a Terminator hand, I have a gazillion little crevices all over the surface. And if you have crevices, you can't clean it fundamentally. When you talk about bacterial harborage of E. coli, salmonella, if you have only a few cells left in a surface, that's more than enough to actually create later on a foodborne illness outbreak. So our structures are fundamentally different, right? We have continuous elastomeric bladders that are mating typically into plastic and steel hub assemblies that allow you to create a hand structure that's incredibly dexterous, like those Terminator-style hands, but simultaneously have almost no crevices on the surface so that you can clean it out and it will be very, very safe. And at the same time, we are also, since material science is a big part of what we do here, we can select for things like all FDA-approved materials or whatever is the material safety standard that you want to hit. We can build that into our systems so that you can build incredibly clean, safe robotic systems in ways that you normally couldn't with normal technologies. And it's very exciting. Something came into effect a few years back, the Food Safety Modernization Act. It is the biggest overhaul in the regulatory infrastructure that guides the creation of food in about 70 years. And it was in response to some pretty horrific and dangerous outbreaks of bacteria in people's food. And so the US government has really focused on how to bring us all safer food. And one of the ways you can do that is with a robotic system. So if I have one of our grippers, which is incredibly cleanable, and I do that in a process where the washing of that system is automated as well, and I surround it with other pieces of infrastructure, again, very cleanable, you could start building robotic food factories that always deliver a safe product that you can rely on. So you can do gripper swaps with our systems. Many of the applications that we work in, you don't, and the reason why is that because we offer adaptive gripping, you can grab many, many different grass targets with a single structure, which is technically impressive, but also delivers incredible value to customers. So in one particular application, we're moving dough balls that are being rolled and need to be moved onto cooling trays before they drive out to pizzerias. And the customer that we were working with, when they took a traditional mechanical approach, there was 5 different size dough balls, so they were building 5 different size mechanical grippers. Gripper swap, gripper swap, gripper swap. And so that adds complexity, that adds cost. With our systems, they're able to grab all 5 sets of dough balls, all with a single construct, because again, you just inflate until it makes contact with the surface, and the pneumatics and the ways in which the elastomers and the plastics work, it innately finds the correct grip on what is an incredibly deformable and variable grass target. If you ever play around with dough, you'll notice that When it sits on a table, it slowly rolls out, so its shape's changing. As the water evaporates off the surface, it goes from sticky to slippery. If you try to lay hands on it, you'll squish right through it. So it's this incredibly complex grass target, provided a really fun challenge to solve. And because of the adaptability of our technology, we were actually able to sell them one gripper that did all five. What's better is to do one gripper that can do many different sizes and shapes. And ultimately that's because you don't have turnover times. So there's the cost aspect if you don't have to buy so much gear, but you also don't, every time you do a gripper swap, that robot's not doing work. So if you can get a gripper that's hyper adaptable, then the robot's always doing work, regardless of what's coming down the conveyor and being presented to it. Food work is interesting because a lot of these jobs, people in robotics always talk about robots doing the dull, the dirty, the dangerous jobs. So, think about what it's like to work in a chicken factory, for example. It's refrigerator-like temperatures at your workplace. It's a very wet environment. You typically are gowned in all sorts of smocks and whatnot because there's chicken goop everywhere. And you're working around a lot with just cutters to work the work part, the meat. And so this is a dirty job. It's very repetitive, it's a dull job, and it can be a very, very dangerous job in a very inhospitable environment. So being able to offer solutions that can satisfy those needs and make sure that people have good, clean food on their table is, it's exciting for us. It's a very, very promising application as well.